All right, chapter 21, problem 64. We have a heart pacemaker which fires 72 times a minute. Each time a 25 nanofarad capacitor is charged to 0.632 of its full voltage. So what is the value of this resistance? All right, so we have a frequency here of 72 per minute, which means that we have a frequency of 72 over 60 seconds, right? Which means our period is 60 seconds over 72. All right, 60 seconds divided by 72 equals 60 divided by 72 is 0.833 seconds. That's our period. Now, that is how often the capacitor reaches 0.632 of its full voltage. Well, the voltage across the capacitor goes as V naught, which is the full voltage. V naught's full voltage. 1 minus e to the minus t over RC. All right? So that's the equation for the voltage across the capacitor as it's charging through some internal resistance. Now the question is, what is that internal resistance? All right? Well, I'm going to go through this the long way rather than take the shortcut. The shortcut is I know that 0.632 that RC that the time equals RC, right? That it equals one time constant. But we're going to go through this the long way. So we have 0.632 V naught, because that's where we reach, equals V naught times 1 minus e to the minus t over RC. All right? And we know at that point that t is equal to a period, right? 0.833 seconds. We know that at that point. So the V naughts divide out, right? There's no V naught. We end up with e to the minus 0.833 seconds divided by RC equals 1 minus 0.632, which is 0.378. 1 minus 0.632 is 0.368. Yeah, 368, right? And now I'm going to take the natural log of both sides. So natural log of e to the minus 0.833 seconds divided by RC. Not do that different. To the minus 0.833 seconds divided by RC is just, the natural log is the inverse function of e. So this is just minus 0.833 seconds divided by RC equals the natural log of 0.368. All right. So in the natural log of 0.638, log of that is minus 0.9967. Minus 0.99967. Was there 3 nines or 2? 3 nines. Okay, so that means RC equals, the minus signs divide out, RC equals 0.833 seconds divided by 0.99967, right? Which that's going to end up being 0.833 or 0.834 seconds. All right. Resistance then is 0.834 seconds divided by the capacitance, which is 0.834 seconds divided by, our capacitance was 25 nanofarads. 25 nanofarads. A nanofarad is 834 seconds divided by 25 times 10 to the minus 9 farads. Okay, so 0.834 divided by 25 e to the minus 9. Okay, so 3.336 times 10 to the 7th, which is 33 mega ohms. 33 mega ohms. And that's it for problem 64.